and sees the video. Okay, so we'll start now the class. All right, so you said you are in grade 4th. Where are you from, Arya?
No, sir, I'm in grade 3rd.
I mean, you are moving to grade 4th, correct. So where are you from?
I'm from India.
Oh, that I know, but India where?
Pune.
You are from Pune? Oh, that's nice. Even I am in Pune only. Pune, where? Which school do you go to?
CMS.
CMS, and what does that stand for?
Chinchwad Mallari School.
Okay. You are in Chinchwad. Okay. So see, this is basically when we learn maths, one is you learn in your school. Okay, you learn concepts. Okay, you learn concepts and you apply them, right? This is a little bit on Olympiad kind of a maths, which talks about problem solving. Maths is always about finding out, figuring out. Correct. It is not like general knowledge. For example, you know 5 plus 3 is 8. Correct.
Yeah.
So there is no big deal about it, right? Or you know that 5 into 7 is 35, correct?
Yeah.
Correct. So that is something which you have learned and you're memorized, correct? Here you'll have to figure out. So even if it is difficult, you should not say that I have not learned this. Maths is not about whatever you know, applying that can you find out, okay? So the first chapter, can you see my screen right now?
Yes.
Okay, so we are going to follow a book here. Okay, it's an Olympiad book from Singapore. Okay, the first chapter is looking for a pattern. So maths is also about sometimes finding out a pattern that what is happening. Is there a pattern to it? Okay, so there are various kind of patterns. Some are very straightforward patterns and others are a little more challenging. Okay, so sometimes we have to think and understand that what is happening there. Okay, we need to be observant enough. Okay. So before I start patterns and on this one, let me tell you, there are two basic kind of patterns which you need to understand. Okay, patterns. Now patterns need not be always with numbers. Okay, it need not be always with numbers. It can be any shape also, it can be anything. For example, if I draw this, okay, what will be the next one here? What will be the next shape?
Circle.
How did you get that? You saw that it is repeating, correct? It is alternating. Yes. So there's a triangle, then there's a circle. So patterns need not be always this thing. Okay? And this particular pattern, and then there are patterns which grow. For example, if I write this pattern, okay, 2, 4, 6, 8, 10. What will be the next one?
12.
Correct? That's an even numbers which are just a skip counting of 2. Correct? We are listing them. So this is called a kind of a pattern which is called a growing pattern.
Okay.
Growing pattern need not be always growing only, it can be reducing also. For example, if I write 99, 97, 95, 93, what will be the next one?
91.
Fantastic, fantastic. Understood. So it's a reducing pattern. Okay, but it's again a pattern which is moving on. Okay. Now there are patterns. This can be also called a pattern. Now there can be patterns which are kind of, you see, you tell me in this one, okay? Okay, tell me the next 4 terms. What will come here?
25.
It's not 25, it's 2514.
Okay.
So what next 2 will come?
2514.
So this is a repeating pattern, right? It's
okay.
a repeating pattern. It is like a circle. So let's say you go in a circle. From 2 you are going to a 5, then you are going to a 4, and then you are going to a 1, and then you are again coming back to 2. Correct? Correct or not? Right?
Yes.
5, 1, 4, and back to 2. Sorry. Right? In a repeating pattern, this is a repeating pattern of 4 terms. These are called, each one of them is called a term, correct? Right? It's a repeating pattern of 4 terms. In this, there is a very good thing, you know. The good part is that if you add all of them, what will you get? 2514. Do in your head. You don't have to do a copy. It's very easy.
12.
Correct. So 2 plus 5 is 7. 7 plus 1 is 8. 8 plus 4 is 12. Very nice. Now notice this. What is happening? If I leave the 2 and I take the pattern from here and I again take only four terms, 1, 2, 3, 4, the sum will be still 12. Correct? Because we left the 2 and we then included the 2. Correct?
Yes.
So understand, in a repeating pattern, whatever the sum is of 4 terms, or whatever the size, this is called the size of the pattern. There are four terms. This is the size of a pattern. Correct. So if we take the same size and we take from wherever we start, okay, it will be always 12. So this is 12. Now if I add from 5 and I go till 2, I will still get 12. 5 plus 1 is 6. 6 plus 4 is 10. 10 plus 2 is 12. And if I start from 1 and then again I go for 4 terms only, I will again get 12. 1 plus 4 is 5. 5 plus 2 is 7. 7 plus 5 is 12. If I start from the 4 instead, okay, and go till 1, I will still get 4 plus 2 is 6. 6 plus 5 is 11. 11 plus 1 is 12. So it will be always 12. Understood?
Yes.
In a repeating pattern. Okay, so that's one of the features of a repeating pattern. Now, repeating pattern again need not be always numbers. It can be anything. It can be anything as long as it has the same repeating thing and it is coming in the same order. Okay. So, for example, if I write triangle, circle, square, okay, then again another triangle, and then again triangle, square, circle, triangle, then again triangle, square, sorry, circle, square, triangle. So here you will notice in these are all same, correct?
Yes.
And it's a repeating pattern of 4. So if you start from anywhere, if you start from anywhere, let's say you start from the square and you go for 4 terms, then every pattern as you saw earlier, let me just take this one off right now. What is happening? Why it is not going? So if you notice here, in one pattern, you have 2 triangles, 1 circle and 1 square, correct?
Yes.
But if I go from anywhere, let's say I start from this square here, okay, this square here, and I go for 4 terms, 1, 2, 3, 4. I will still get 2 triangles, 1 square and 1 circle. Understood?
Yes.
It will be always the same things. It might be in a different order, but it will be always the same thing. And that is the reason why in a pattern, if it is numbers, the sum will be always same. Okay.
Okay.
Okay. And if it's a shape, then you will have the same elements again if you go for 4, any 4, consecutive. One consecutive means one after the other. Okay.
Okay.
All right. Okay. So this is called a pattern. Okay. Now let's do some problems here and let's understand this. So after this, we see that besides adding or subtracting the terms in a number pattern, applying multiplication, division, or even the use of any 2 arithmetic skills may help in the solving of a problem. Then they are talking about a Fibonacci number. In a Fibonacci number, the third term in the pattern is the sum of the first and the second terms. So the last 2 terms we add up to get the next one. Okay, the fourth term is the sum of the second and third terms, and the fifth term is the sum of third and fourth terms, and so on. In essence, each term after the first 2 terms is the sum of the last 2 preceding terms, the ones which are before that. Okay, so now let's do some examples here. Okay, quickly. Let's do this one. So it's saying complete each number pattern. So you have to tell me what will come in the bracket.
16.
Correct. So how did you observe that? What did you observe?
We have to add just 3 numbers and then it will come 7, then 10, then 13, then 16.
Correct. So when you observed this, you saw that 4 plus 3 gives you a 7. And then a 7 plus 3 is giving you a 10. And then again this plus 3. So every time you are adding 3 to get to the next one. Correct. It's like a skip counting of 3 also. But it's just that it's not starting from 3. It is starting 1 after 3. So if we had done a skip counting of 3 and we've done 3 stable like this, 3, 6, 9, 12, 15. So you notice here that the first one is 1 more than that, correct? The first one here is 1 more than this one, correct?
Yeah.
Similarly, therefore, because it started 1 ahead on the number line. Okay, so let's say this is a number line, okay? And if I'm going by 3s, so I have a 3 here. I go by 3, I reach a 6. Then I go by another 3, I reach a 9. Then I go by another 3, I reach a 12. 15, correct? Now, if I start only 1 ahead over here, okay, I start from a 4, then every time I have the same size jump. My jump is still same in both cases, correct? Here also it's 3 plus 3 plus 3. Here also it's plus 3 plus 3, correct? So my jump size on the number line is same. So every time I go jump from here, because I had a head start of plus 1 here, I will reach here also plus 1. 6 plus 1 is 7, correct?
Yeah.
Then I again take a jump here, I will reach a 10. So there will be 1 more than the 9, correct? Then again I take a jump of 13, I will reach a 13. It will be 1 more. And again I take a jump of, it will be a 16. So very nice. You good observation. This is just an additional information for you to understand. Okay, which we will use later on maybe sometime. Did you understand? Because the jump size is 3 only, and because you started 1 ahead of 3, you will always, all the terms here are 1 more than this. If you notice here, 13 is 1 more than 12, 16 is 1 more than 15, 10 is 1 more than 9, and 7 is 1 more than 6, correct?
Yeah.
Okay, all right, good job, 16. All right, let's do the next one. Okay, someone is joining us. Pranshu is joining us. Pranshu, video on. All right. So in this one, just notice this, what is happening. Pranshu, you can answer on chat, okay?
Okay, sir.
Don't give the answers because Supriya is very new to all this. Pranshu is my student, so he's been studying with me for some time. So Pranshu, tomorrow, listen, Pranshu.
Yes, sir.
Tomorrow evening you're free, na?
Yes, sir. Tomorrow evening I am free.
So tomorrow evening we'll sit at around 7, okay?
Okay, sir.
Okay. Okay. Yeah. So in this one, Supriya, let's see what is happening. Not Supriya, sorry, Arya.
Yeah.
Try to figure out what is happening. You write it on a copy and see what is happening, what is the gap, how it is jumping.
Sir, I did not understand it.
So what is the difference here, Supriya? Sorry, Arya. What is the jump? From 2 to 6, what is the jump?
4.
Correct. Okay, so let's write a plus 4 here. Okay. Then see what is the jump here.
6.
Okay. Then what is the jump here?
8.
So do you see a pattern here?
Yeah.
What is the pattern? So what will be the next one? How much?
8.
Then what will be the next one here?
Mm.
Ask your mother not to prompt you and help you.
10.
Correct. You have to figure out yourself. Correct or not? Otherwise, what is the fun?
Yeah.
Huh? Hai na? There's no fun otherwise. Then your mother is only solving. Correct. Okay. So it's a 10, right? So what will you get here now? Now think. What will you get here? What will you write?
30.
Exactly. Fantastic. See? So sometimes you have to figure out. You have to find out. Correct. And you will be able to find out only if you do something about it.
Okay.
Correct or not? You will have to start somewhere. Start is very important, right? You start something. See what is, observe for yourself. Okay. Was this so difficult? Not difficult, right? You could have written this, even if you've not. See, you don't need to. That's what I said. Maths, you won't know. If you know what you are doing, then it is not maths, it's general knowledge. Correct or not?
Yeah.
Maths is always about finding out, like solving a puzzle. Okay. All right. Let's do the next one. Even I didn't know. When I was doing it, I also didn't know what to do. I started doing something and we figured it out together. Correct?
Yeah.
All right. So basically, it was increasing by 2 every time. The difference.
Okay.
And always remember, let's say in the book, it's given in a different way. Okay. Solutions always in maths can be done in different ways. Okay. Like I can add to get something. I can multiply to get something. For example, if I have to, say a teacher gave 5 chocolate to 4 students. Okay. If you know the table, you will say, okay, 5 into 4, 20. If you don't know the table, you can always add and find out, right? 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20. So there are different ways to do it. And at the end of the day, in maths, most of the problem will involve only counting. It is only addition and multiplication help us to do it faster. But at the end of the day, it is all counting only. It's a count of a number, correct? Okay, now let's do this one, next one.
Okay.
Okay, maybe here it is not a addition or a subtraction. You have to think in terms of what is happening in.
Right.
You know the tables, right?
Yeah.
Ranshu, you are moving to grade 5 now, right? Or 6?
So 5.
5. You come back to Mumbai or still in Odisha?
I'm still in Jharkhand. Actually,
Oh, Jharkhand, sorry.
Actually, my final exams will be starting from my March. So we are planning to go from here on the Feb last.
Feb last, okay.
Because my exams will be offline.
Ranshu, did you figure this one out? Don't always think addition only. It can be anything. Arya, how many times 6 is of 2?
3.
Do you see that now a connection between the 6 and the 18?
Mm, are 18.
So 2 3s was 6, correct?
Yeah.
And then the next one is 18. Now what we have to do now? Now you understood?
Yeah.
That's it. What did I tell you? I told you also, not every time you have to think from addition, subtraction only.
I think it's 64.
No, 18 into times 3 is not 64. You've done some mistake. Just check. Arya, how much is
54.
yeah, correct. So how much is 3 times 20? 20 if you go do skip counting of 20, then 40, then 60, right? So
Yeah.
when you get an answer like that, like 64, you need to think, oh, did I do something wrong? Because 20 is more than 18, correct? And if 20 times 3 is only 60, then how come 18 times 3 will be 64? Correct or not? Sometimes when we make mistakes, we should be also always thinking that what is my approximate answer should be. Okay. It should
Okay.
be a little less than 60, correct? Because 20 times 3 is easy. Because see, 2 times 3 is 6, correct?
Yeah.
Therefore, when I multiply this whole thing by 10 and I group these two, it becomes a 20. Right? So 20 times 3 will be equal to 60. Right?
Yeah.
All right. So very nice. So we can see how you can break it up. Let's say you don't know the table of 18. Okay. And you don't know the table of, but you know the table of 3, correct?
Yeah.
So I'm saying, what do we mean by 3 times 18? We mean by that you have a 3 here. From 0 you are starting. Okay, 0. So this is your 1 3, correct?
Yeah.
Then a second 3, correct? And
Yeah.
that makes you reach 6, correct? Then another third 3 makes you reach 9. So like that, you have to take 18 jumps, correct? And wherever you reach on the number line, that becomes your answer, correct?
Okay.
So can we break it into 10 jumps first, which will give you a 30, correct? So if I do a 10 jump first, the 10th jump here, will give you make you reach a 30, right?
Yeah.
And 18 is what? 18 is 10 plus 8, right?
Yeah.
So I got to a 30, then I need to take 8 more jumps, correct? Right? And 13, 3 into 8 also, you know, how much is that? 24, correct?
Yeah.
So 30 and then another 24. 30 plus 24. Where will it make you reach?
54.
Correct?
Yeah.
Or you can think, okay, I did 20 jumps of 3, I reached 60. Right? I have to take 2 less jumps. So 2 less jumps means 60. From there, I have to come back 2 3s. Correct? So I'll come down to 57 and then a 54. That's 60 minus 6. So there are many ways to calculate. Understood or not?
Yeah.
It is just break down your calculation. Okay? All righty. Let's do the next one. In this one, I also don't have any clue what to do. I understood now. I guess I understood. Sometimes the pattern might be that there are two things which are happening. Think in that way. First, see what happened to the 44. What happened to the 44? What happened to the 44 that it became 22? What happened? What do you think? Think.
We did 22 less of it.
Only not less. Okay, if we look at that way, that is one way to look at it, that this is minus 22. But what is 22 of 44? Do you know? It is half, correct?
Yeah.
So maybe we have halved it, correct? Because not everywhere there is 22, correct? We don't see a 22 again difference, like, correct?
Yes.
And then what did we do here? Here maybe we just did a minus 2. So here we divided by 2 first to get a 22, and then we did a minus 2. We got a 20, right?
20.
Then we again do
Yeah.
half the 20. We got the 10, correct? And then we
Yeah.
again subtracted the 2. We got a 8. Now the next thing what we are going to do is division, subtraction, division, subtraction. Next will be again division by 2.
Yeah.
Correct? So that will give me how much? 8's half is how much?
8's half. 4.
Correct? Okay. And then again we'll do a subtraction of 2. 4 minus 2.
2.
Did you understand? So pattern need not be always having the same operation also. Sometimes the patterns will have something like this. Okay. Sometimes this is one operation after the other. Sometimes the question could be like this. Okay. Now tell me in this one, what will be? I'll explain to you this one. This one you won't be able to do maybe. Okay. In this is an alternating pattern. Like a 3 is going to a 9, which is multiplied by 3, correct? When the
Yeah.
9 is getting multiplied by again 3, it is getting a 27, correct? And we are skipping one number in between. Can you see?
Yeah.
Then again, I'll multiply it by 3, so I'll get an 81 here. Okay, so in one pattern, I'm multiplying the 3 by 3 every time. Okay. In the other pattern, I am going by skip counting of 3 only. So 3 plus 3 is 6. 6 plus 3 is 9. So the next one here will be a 12. Did you understand? So this is kind of an alternating pattern. So patterns are different. Sometimes it's a little difficult to observe and understand, but you have to do something to start with. Okay.
Okay.
Not every pattern will be easy, but it's okay. Now let's look at this one. This is the one which we spoke in the examples, which was a Fibonacci. Okay, now let me explain to you this one, then you do the next one. Okay.
Okay.
So 1 plus 1 Fibonacci, what it does, that whatever the terms before it are there, the last 2 terms it adds. So we start with a 1. The next one has only one term, 1 itself. So we take 1 and we put it over there. Okay. Then the next one here, you add up these two. These two. Okay. You add these two up. Okay.
Yeah.
So you get a 2, correct?
Yeah.
In the next one, if you add the 1 and 2 here, you get the 3.
Yes.
Right? The 5 you are getting by adding these two. 3 and 2 is 5. Right? And the 8 you are getting by adding the previous two, 3 and 5.
Yeah.
Right? Okay, then again the 3 plus 5 is giving a 8. Then add the 5 plus 8, you get a 13. Correct?
Yeah.
So what will you get here? 8 plus 13, 13 plus 8.
21.
Correct. Then you add another 21 plus 13. What will you get the next one?
34.
Correct. Now see, 34 plus 21 gives you the 55, and the 55 plus 89, whatever it will be. Okay, so this is called a Fibonacci. This is called a Fibonacci series. Okay.
Okay.
And there is something called a Fibonacci. Fibonacci, what it does, it adds the last 3 terms. Okay, for example, if I start with a 1, the next one will be 1. The next one will be If you don't have anything, then whatever we have on the left, we add it up. So 1 and 1 is 2. Correct. And now the next one will be 1 plus 1 plus 2, which is 4. Okay. Then we will add the next one, 4 plus 2 plus 1. So that's a 7. 7 plus 4 plus 2. So that's a 13. 13 plus 7 plus 4. That's a 24. And that's how you go. That's called a Fibonacci. When you add the last 3.
Okay.
Tree stands for triangle. 3 sides like that. Tree means tri. Tri means 3. Correct.
Okay.
Alrighty. So let's do the next one. Let's see what else we have here. Okay, now there are some practice here. Okay, some problems here. Okay, which are given. Okay, but some are answers are written here. So we'll do till in this one till here. We'll do all this and then we'll in the next class we'll continue. This is again, observe this, what is happening. It is something similar to what we did just now.
Yeah, we just add 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5.
So the next one,
1 minute, sir.
you're doing it correctly. Next one will be what?
Is it 8?
Correct. Why? You have to doubt yourself. Absolutely correct. Next.
$13.
And start visualizing the numbers, how the numbers are. See, you are doing it on your finger, correct?
Yeah.
Understand this. Always look at the numbers in this way. Maybe this will help. At least I look at it in this way. This is my style. I'm just saying. Okay. So you are adding a 8 plus 5, right?
Yeah.
8 and 2 will make you reach a 10, correct?
Yeah.
And you have to reach a 5. The 5 is what? The 5 can be broken down into a 2 plus 3, right?
Yeah.
And then you go 3 numbers, no? In your mind. So you visualize this. 8 plus 2 is 10, 2 plus another 3 is 13, correct? Okay, cool. Let's go to the next one. Okay, and don't cheat from here, okay? So
Okay.
I'm just taking from here only. You have to write the answer here. This is also something which, so the previous question which we did was a Fibonacci.
Yeah.
This is what it is. Let's see.
Mm. 7, 8.
It is actually adding last 4 numbers.
Yes.
If you notice in this, it's adding last 4 numbers. Still here, they did not change anything, but from here onwards, changing. All this adds up to 4. Then if you notice, 4 plus 3 ones will give you a 7. 7
Yeah.
plus 4 plus. So this one, what will you get here?
7 plus 4 plus 7, 8, 9, 10, 11, 12, 13.
Again, you are doing like that. 3 plus 7 is what?
What?
3 plus 7 is what?
10.
Why? You need to know these things, okay? This is your homework, okay? You need to know number bonds. Number bonds means 1 plus 9 gives you a 10. Okay? 2 plus 8 gives you a 10. Okay, so for 10, the number bonds are 1, 9, 2, 8, 3, 7, 4, 6, 5, 5. Correct? Similarly, for 9, what are number bonds? Like 1 and 8 gives you a 9, 2 and 7 will give you a 9. So you should know these things. Every time if you start counting on your finger, that will take you a lot of time. Understood?
Okay.
So practice that. Practice writing the number bonds because that will help you. Understood? A 13 plus 3 plus 7, you should know 3 plus 7 always gives you a 10, correct? So if you have already a 10 extra, because the 13 has a 10 plus 3, correct? It already has a 10, right? Correct? So this 3 plus this 7 will give you another 10, correct?
Yes.
So that's 20. Simple, na? 3 plus 7 is 10. So 13 plus 7 will be 20. 13
Yeah.
plus 17 karenge, around 13 plus 17 karenge, for example. So what we are seeing, there are already two 10s, correct? And
Yes.
then there is a 3 and then there is a 7 as in the ones place. These two put together gives you one more 10, correct? That's a
Yes.
30. Okay. Chalo, anyways. Yeah, so 30, you said what is the answer now? Tell me in this one.
I just did it like 13 plus 7 plus 4 plus 1 is equal to 25.
And that's correct. Good. Good job. Let's do the next one.
Okay.
All right, let's do this one quickly. This one I won't tell you because this one is similar to what we did earlier.
Okay.
Write the numbers and try doing it. And don't take help from your mother.
Okay. Mm. Sir, I'm confused.
We did something similar to this a little while back. What is it? See, this is not multiplication for sure because 5 is not a table of 3, correct?
Yeah.
You know, we can also see another relationship here that 3 into, maybe this is a multiplication. Maybe. 5 into 3 is 15 and 3 into 9 is this thing. But 9 into 3 again is not a 23. It's a 27, correct? So this does not match, correct? And if I do a 15 into 3 also, it's a 45, it's not a 45, correct? So the
Yeah.
multiplication is not working, okay? Okay, now let's look at what other relationships we can see here. Let's look at a difference. What is the difference here? Plus 2. 2, right? 3 plus 5 is 2, right?
Yeah.
What about 5 and 9? How much is the difference? Come on, 9 minus 5 you should be able to do. Yeah, 4. This one?
6.
So now do you see a pattern?
Yeah. It's table of 2.
Yeah, this one is a 8, correct? 15 plus 8 is 23. 23 plus 10 is a 33. 33 plus 12 is a 45. So the
Yeah.
next one will be a plus. Plus
Mm.
what?
Plus 14.
And that gives you how much?
Um, 59.
Good job. Yeah. Understood?
Yeah.
So we did this kind of problem a little while back, Arya. What did I tell you? Don't give up so easily. Okay. You don't give up. Okay. If something doesn't work, again try with something else. Okay. Don't give up. Right. This is not a exam, a time-bound exam, right? Right now we are all learning, right? So don't give up. When you're practicing, don't give up easily. All right. Let's go to the next one. Okay.
Mm. Mm. Is it 15?
Correct. You don't ask me. You can always check it. Correct. See how you can always check is that you first wrote the difference. Correct here, and you said
Yeah.
it is 2. Right. Then you
Yes.
saw that the difference here is 3. Correct.
Yeah.
Then you notice that the difference here is 4. So looks like a pattern, right? 2, 3, 4. So it's like consecutive numbers. Correct.
Yeah.
So next one can be a 5. Can be. Let's see. So
Yeah.
we put a 5 here and we got a 15. The next one should be a 6 here. So you
Yeah.
can always check if I'm adding a 6 to 15, am I getting the same thing what is given there? 21, correct? Isn't
Yeah.
it? So that's how you check also. So you get a 15 plus 6 is 21. Looks so far so good. And plus another 7 if I add, I get a 28. That's also okay. Which means
Yeah.
my thinking that there is a pattern of consecutive numbers is correct. And then 28 plus another 8 is 36. All right.
Yeah.
Okay, Arya. So you've done fantastic. I think we should call it a day. I really enjoyed teaching you. Okay, you are a good student. Okay, and you are very obedient and a very nice girl. Okay, and don't give up. Okay.
Okay.
So maybe next Sunday, if we are doing, we can always catch up. Okay.
Okay. At what time?
Same time around 12.
Okay.
Okay. Did you like it?
Yeah.
Is this interesting?
Yes.
This is not even interesting. This is a very boring topic for me. When we do some other topics of word problems and other things, it will be more fun. It will be more fun. Where we will solve problems using drawings.
Okay.
Okay. So we'll continue next week a little bit about patterns also, a little bit, because I need to do the repeating patterns also, because repeating patterns are very interesting and we need to do that also. Okay. And but you understood this, right? So what you do is that try to write some Fibonacci series. For example, or see, you can make patterns on your own. So let's say I start with a 2. Okay.
Yeah.
And next number, let me write anything. Let me write a 3. Okay. So 2 plus 3 gives me a 5. Right? 3 plus 5 will give me a 8. 5 plus 8 will give me a 13. Like that, you can make some patterns. Okay.
Okay.
Similarly, you can make mixed patterns if you want to make a mixed pattern. So let's say you want to make a mixed pattern. And you say that, okay, I will double everything. So I have a 1 here. Okay. And I will leave one space here and I double the 1. I'll get a 2. Then I double the 2, I get a 4. Then I double the 4, I get a 8. I'm just giving you an example. You can do whatever you want. You can double it, triple it, whatever. And here I will just add things. Okay. So for example, I start with the 3 here and I'll keep on adding 2's. So 3 plus 2 will give me a 5. 5 plus 2 will give me a 7. So this became a pattern, alternating pattern. These are called alternating patterns, correct?
Okay.
Okay, then we saw that we can have patterns with alternating operations, like we saw that, correct? There was one where we had a 44. The 44 was first halved, 22, and then a 2 was subtracted, correct? Now let's say instead of subtracting 2, if I added 2, it will become a 24. Then I again half it, it will become a 12. Then I add again 2 to it. Okay, I'll get a 14, correct? So
Yeah.
half, then plus 2, then half, then plus 2. Okay, then again half, no, sorry, not half. Yeah, half, right? Plus 2,
Yeah.
12 plus 2 is 14. 14 is half is 7. Okay, 7 plus 2. Okay, will give me a 9.
Yeah.
9. But now I cannot half it anymore. The problem here, correct?
Yeah.
So like that, you can try making some patterns and then try to figure it out. Okay, so patterns are interesting because that just gives you kind of a, trains your mind how to see the patterns. Okay, and that is very important in mathematics because a lot of things also depends on patterns. A lot of things depends upon pattern. You make a problem, a big problem into a smaller problem. Okay, for example, if I tell you, okay, right now I think it's too early to give you those kind of examples, but we'll see some other time. Okay, chalo.
Okay.
So do you like maths or not? Or do
Yes.
you like?
Yeah.
So one is that you are counting this the addition and all on fingers, which is fine, but now get used to doing the number bonds. So you will find number bonds you can make. So you need to know these things. That okay, for example, if you have to make a 1, what you can add? 2 numbers. You can add only a 1 and a 0, correct, to make a 1.
Yeah.
For a 2, you can either get a 0 and a 2, which add up to 2, or you can have a 1 and 1, which will give you a 2, correct? Right?
Yeah.
Then for the 3, what also? You need to keep this in mind. Every time you cannot do it on your finger and count and do addition. These things you need to kind of a little memorize a little bit and get used to it. Okay? You should be able to see numbers. Okay, so 2 and 1 is 3. Or that is the only way you can have 3 or a 0 and 3, correct? So 0 and 3 will always, anything with 0 will give you the same thing. Anything with 0 will give you the same thing because 0 is nothing, right? So we won't discuss the 0 part. Let's say a 4 and 4. So you can have a 1 and 3 giving you a 4, correct? Or a 2 and 2, right? And understand the numbers are always in this pattern. They are always in a group of tens, correct?
Yeah.
So that's how you add. For example, if I tell you add 324 with 586, the big number, correct?
Yeah.
Background. So you add these two hundreds, what do you get? You get 800, correct?
Yeah.
2 tens and 8 tens will make you 10 tens. That's another 100, right?
Yeah.
So I'll increase this one, I delete this, and I say, okay, there are 900s.
Okay.
And 4 ones and 6 ones make a 10, correct?
Yeah.
So that's a 910. But now the ones are no longer there because that's converted into a 10. So this is 910.
Okay.
Understood? So you do now start doing. Okay, chalo then. All the best. Your school is open now.
No.
Or online classes. Online classes.
Online classes.
Okay. Ask your mother to come online.
Yes, sir.
Yeah, you can get a book from Amazon. This book which I'm teaching from, it's called Terry Chu's Unleash the Math Olympian. Okay, so this has got a lot of heuristic techniques. Okay, heuristic things which are beyond school mathematics. See, school mathematics teaches you very rote learning kind of things.
Okay.
So that book will be helpful for her. You get it for I think 400 or 500, something like that. Okay, and you can make her learn also from that. Examples are given there, so from there she can understand. Okay, so that will help. It's actually based on Singapore Math Olympiads and all.
Okay. Huh.
Yeah. It's I'll tell you the book's name. One second.
Yeah, that's what I wanted to ask you.
The book's name, Maths Olympiad, Unleash the Math Olympian in You. The author's name is Terry Chu. And you need to get the beginner level. There are many levels in this. Beginner level is apt for grade 3 and 4. Suitable for 9 and 10 years old.
Okay. So pardon, beginners Olympiad, no? Beginners Maths Olympiad.
No, it's I mean, the level of this book is for grade 3 and 4. That level is called beginner.
All right.
Okay, so this book you can get it on Amazon, and it would be helpful for us. So, all these chapters we started just now with this one, patterns, but a lot of things are there which are not taught in the Indian curriculum. Logical thinking, a lot of things solve using models, word problems, age problems, problems on speed, journey, and all that, which are normally taught here only after grade 5, 6.
Right.
Okay. And that's then there is a huge transition when children suddenly from learning all abstract things and rote learning, they are suddenly introduced. So the transition has to be gradual. So they need to start learning these things, and these are very explained in a very beautiful and easy way, rather than the complex methods of always using equations. For example, I'll tell you, Singapore uses something called a bar model. A bar model tells you about visualizing things. You need to learn maths using visualization. I say a father's age is 4 times the son's age, and the difference of their ages is 30 years. Typically, the way we have been brought up, we will solve it in this way. We'll say, okay, son's age is x, father's age is 4x. Okay, so 4x minus x is equal to 30. 3x is equal to 30. Therefore, x is equal to 10. And therefore, father's age is 4x is equal to 40. Now, this is something which in Indian schools, suddenly word problems will come, and children, so far they have been doing only operations, mathematical operations, addition, subtraction, multiplication, even though without understanding where to apply what. Okay, just rote learn. Okay, and then suddenly you bring in a word problem, they struggle with making these equations, correct? These kind of equations.
Right.
Now, over there, Singapore, they make the children understand the relational aspect. So they will make children from kindergarten maybe playing with blocks, but later on, once they are in grade 1 and 2, they draw. So let's say they say son's age is this, and father's age is 4 of this, correct? So the difference we can see here, 3 of this, correct?
Right.
And this 3 of this is equal to 30. This is equal to 30. So each one is 10. Now this block is nothing but the x only. But why make it scary? Make them visualize, na? Make them visualize. So when they start doing word problems and application-based learning, okay, then they learn better, because then the transition from a grade 3, 4 to a 6, 7, and then those things are much smoother, because then they understand maths. They can relate to it, not rote learn things and then struggle to make equations and other things.
Fine.
So that's the whole idea. So
okay.
Right.
So,
Okay, so
the earlier videos, can we be able to see them, or how should we?
those are all on the YouTube channel.
Okay.
Global Olympiad second. So the previously, see, till last week I have introduced my own competition, GJ Mat. Okay, so in the till previous week we were doing all the sample papers of this grade levels, which right now, gauging her level, she might find difficult. Okay, but still let her watch it and maybe you can explain it to her. Okay, it's not that difficult also, for an adult, but for a child it might be difficult, a little difficult, especially if they are not used to these Olympiads. Because I don't think the schools here in Pune or anywhere else for that matter, they give emphasis on application-based learning. Is she going to which kind of school, which board she goes into?
Right now she's an SSC board, and we have tried for this Olympiad from our Indian Olympiad, SOF. SOF
is just an extension of school studies only. That's why in SOF Olympiad,
Okay.
even an average student will easily get out of 50 or 30, 35. And a good student will
Okay.
do even almost 100%. Because it doesn't
Okay.
challenge you enough.
Right. Okay. Maybe.
It doesn't
Yeah, this
challenge
was
you
the
on your
first time I
thinking.
just.
They will just check your rote learning. They will give you a question and see if the child can calculate fast or not. We are not, you see, if you are trying to make children as calculators only, then it doesn't make sense, right?
Fine, sir.
Okay, thank you so much.
Yes, thank you, sir. Thank you. Yeah.
Thank you.